look like. This is the first one. Any question up to now? Now, let us go to the next one, this one, okay, add carry. So, add carry means, in fact, indeed, okay, this one, ABC means A plus B plus carry. Okay? So, this means that I should put the carry there, isn't it? So, how can I put the carry there? By making this one 0, 1. So this should be 0, 1. And what is the function of this one? It is executing the same function, the add, isn't it? Because I have there the carry, and this do not know whether this one is 0 or 1. So therefore, this is still 0, 0, 0. Okay? Now, is it possible that we are going to have a carry? Yes, by adding 3 numbers together. Yes, therefore we are just loading it, putting it in the memory, the carry.
But why are we putting select C in 0, 1?
Because it is actually the carry here. That is at least what you have put here.
Okay, okay.
0, 1 means we are selecting it and putting it there. So therefore I have there exactly my carry input. Okay, that's according to this one, okay? Not to something else.
Okay.
I don't know who put this actually on the whiteboard, but this one.
Okay.
Okay? Any question? Now let us do the sub 2, okay? This is actually the sub, and this one subtract with carry, okay? These are the instructions. Now,
how it's for the CACB 000?
this is given. This is given. Add function means that CC, CV, and CA must be 0, 0, 0. Okay?
001 here.
Which one?
ABC.
0, 0, no. Ladies and gentlemen, you have here actually 2 tables, okay? Actually 1 table with 4 possibilities. This. So this part here, 0, 0, 0, 0, 0 is add. 0, 0, 0, 1 is add C, okay, etc. And this part here, this is actually 0, 0, 0 means add for the ALU slice. Why? Because the CA here, the CV and CC, has nothing to do with this one there. They are the inputs of these. If you don't understand this one, your level of abstraction is a problem. Yeah, we have clearly there, we have stating it there. CA, CV, and CC. If these are 0, 0, 0, then we have the add function. Is this 0, 0, CA, CV, and CC? So that is going to be the add function? No. It is this one there, the CA and CV and CC. So if this one is 0, 0, 0, 0, which block can execute that function? This one here. Okay, therefore, this one is the big one, and this one is the ALU slice. Okay, and 0, 0, 0, 1, that's why it is not corresponding to this one. It is corresponding to this one. But you should see it by looking at your inputs and outputs. That's why we can also explain this, of course, but then not at 4 here. Okay? Clear? Why it is that? Now we will come to, do you want to, let's omit then the add and add carry and do the other things. I don't know which one. Huh? Yeah, we're going to combine it in days. Why? Because we are doing exactly the same, okay? With sub means that my borrow is going to be 0. So this input is going to be 0. And with sub C, this one is going to be, again, the borrow that I put in my memory. Okay, that's exactly the same. So my ALU slice is going to be executing exactly the sub operation and nothing more than this. You remember what we have said? While we were studying the functional decomposition, the main goal is that you are going to rewrite the functions or recognize the similarity between different kind of functions so that you can combine them. You remember it? That's exactly what we are doing. Okay, so we see that sub and sub carry, they are similar to each other. The only thing is the carry input or the borrow input. Okay, you should make it 0 or 1. And in this architecture, it is possible to make it 0 or 1. Yes? Okay. Can you do it now? The rest?
Yeah.
Or should we do one of the functions? I don't care. For example, shift left and shift rotate is exactly the same. It is depending on this one there. Are you going to take this into account and shift it? Okay, that's the only difference. So that is coming by the next one coming here. Okay, so we are combining these two also. But let me omit these things. Sub C and subtract carry. Carry is the same. Let's go to this one here. Okay, let's use, for example, the NOT operation. Yeah. So at the first place, we should code the NOT operation. Did we code it in our no? Which code you are using? This is for this one, okay? Because I should tell here, I would like to execute the NOT operation. So, well, how are you going to code it? I don't know which one we didn't use. For example, 1, 1, 1, 1. Okay, so if I have this one, then I'm going to do this. Good, very good. We have adapted the architecture, so it means that we are going to have this one as output. Now, some people is going to define it only for this one. That's not correct, because the output is now there. Therefore, for this function, you should define it too. So this is add. We are going to add accumulator plus OP and D. So it means that I should have here the OP and D. So what is my OP and D? Which code? 1, 0. Therefore, my cell M should be 1, 0. And here too. Okay, and continue in this way. You understand? 1, 0 means that I'm selecting this one there. And how do I know it? I put it there. You can put there something else, of course, no problem. Clear? Because if I don't choose here the OP and D, I cannot add OP and D plus accumulator. That's why I should choose for the OP and D. I've done it. And so you can define it for the other functions too. Let's go now to this one. Okay? NOT. So what I know from my first year course, okay, if I have something like this, and we have discussed it in Digital 3, it was a very, very, very simple architecture. You remember, NOT and then XOR. So if I have here A XOR B, what is my result now? If I have this from your first year course, this is XOR, symbol for XOR. And if you don't understand it, let me write it in this way then, XOR. B. What is my result? What am I going to get from this? Yeah, what is it? I don't care. Tell me what I'm going to get.
Not B.
Not B. Very good. Not B. Not accumulator. That's exactly what I need, isn't it? So therefore, this is indeed, okay, B, not. Now I have my solution. My solution is that the ALU slash should execute the XOR function. And I should put the 1 at one of the inputs. 1 XOR accumulator will give me not accumulator. So I should choose here which function? The XOR function. What is the code for the XOR? 1, 1, 0. So therefore the CA, CB, etc. should be 1, 1, 0. Okay? So therefore the ALE slash should execute the XOR function. And what should be actually the operand, the input to the ALE slice? It should be 1. So my cell input should be
0, 0.
Exactly. So therefore, this, where is it here? This should be 0, 0. Clear? So by doing the XOR, can I get a carry? Normally not. The logical functions are not giving me the okay, the carry. Should I keep it in memory? No. Therefore, what I can do here, put here either 0 or 1. I don't care. And this is also, this input, select C in, okay, the carry is also not important, so I can put here either 0 or 1. I don't care. Okay? Clear? Now solve that show the not AQ. So this one is very easy. Which function should I do? The load indeed. Okay, the load. And load is 1, 0, 0. So if this is 1, 0, 0, and I'm doing actually the set. Okay? So what should I select here? The 1 again, isn't it?
Yeah.
So that the 1 will be loaded in my accumulator. And 1 was 0, 0 again. So this is 0, 0. By loading, is it possible that I can get a carry? Therefore, I do exactly the same there, isn't it? The only thing what I do, use a different function. Okay, use a different function. And the last one is very easy, again, the load by selecting the 0. See, it's not that difficult actually. We are combining all of our knowledge starting from the first year. Look, if you don't understand this one, and you cannot construct it in a different way, then forget it. You can also put there, of course, look, another solution. That's what I'm saying. It is not optimal. What you can do here, for example, okay, just here, okay, put here an inverter, because these are the inputs. Put there an inverter. Okay, and select here the 0 and apply the add function. Exactly the same, not AQ. There are many possibilities. It's up to you what you do. Because I'm not going to check whether it is optimal or not. Yes, that's another way of doing it, for example. Yeah, so it means that you are inverting it. You are selecting either this one or this one. Understand? You select either your accumulator or you select the inversion of it. And I'm adding it with 0. Exactly the same. And there are many ways to bug that, they say always. And what I say, whether it is optimal or not, I don't care.